Hello students, this is a series of videos on teaching students on how to answer chemical analysis questions. These sort of questions are quite common in O level, and I'd like to show you how we can solve this quite easily. Some thinking skills are required, such as analyzing and evaluation skills. How would a teacher think about solving these questions? There are many ways to do that. Some teachers uses the flowchart method as such, where you deduce what are the white PPT and the possible cations or anions present. But I prefer to use the table that we often see in your practical to solve these type of questions. These type of tables. Now, we never begin by looking at the clues or substance from right at the top of the flowchart questions. We look for something very familiar. In this case, the reagents that are found familiar are aqueous sodium hydroxide. Here in this section over here, addition of silver nitrate to W, and something that we are very familiar with, for example, this gas turns lime water chalky. Now, straight away, I will do this one first because the only gas that can turn lime water or calcium hydroxide milky or chalky is carbon dioxide. So straight away, I use a pencil and write carbon dioxide. This will be carbon dioxide gas. Now I look at this familiar reagent called aqueous sodium hydroxide, and I saw this green PPT. So if I look at the table over here, familiar table over here, you see addition of sodium hydroxide, and I look for where can I find a green PPT or light green PPT, and there you have it, a green PPT not soluble in excess, this green PPT. This shows that the solution contains iron 2 ions. Now, however, a lot of students got mistaken. This green PPT is not iron 2 ions. This green PPT has a name, it's known as iron 2 hydroxide. In fact, every PPT here, PPT here, PPT are all hydroxides. So you can safely say that this white PPT is calcium hydroxide. This light blue PPT here is copper hydroxide. This green PPT here is iron 2 hydroxide. This red brown is iron 3 hydroxide. This white PPT here is lead 2 hydroxide, and of course this white PPT is zinc hydroxide. And bear in mind, it's only a hydroxide if you add sodium hydroxide. The same with the aqueous ammonia. The green PPT here is also iron 2 hydroxide. The red brown PPT similar, iron 3 hydroxide, and so on and so forth. So in fact, the addition of sodium hydroxide and aqueous ammonia is to produce is to provide a huge amount of hydroxide ions. We'll deal with this again later. So we know that the green PPT is iron 2 hydroxide. So therefore, this is iron 2 hydroxide. In fact, every time you see a green PPT after addition of sodium hydroxide or aqueous ammonia, that is iron 2 hydroxide. If this is iron hydroxide, and we know that the hydroxide component comes from sodium hydroxide, it leads us to think that where did this iron come from? It cannot come from nowhere. So if you trace back the root, the iron must have come from this solution here. So therefore, you write iron something. If we take a look at another reagent over here, we have silver nitrate, and then for the white PPT. So we refer to the table again, and we can find such a thing. Where can we find silver nitrate? And the result is a white PPT. Yeah, there you have it, silver nitrate, nitric acid, and white PPT. Now this white PPT is not the same as this white PPT because you added in silver nitrate, not sodium hydroxide. This white PPT has a name, is known as silver chloride. Silver chloride. It shows that this solution that have chloride solution in it. In other words, this is silver chloride. So silver chloride. If this is silver chloride and we see that the silver chloride, this product here, The silver must have come from here. And where did the chloride come from, since it's a product of this with this? Yes, the chloride must have come from W. So in other words, green solution W must be iron chloride, iron 2 chloride here, because this is iron 2. So therefore iron 2 chloride. Then we go to another simple part of this whole question. Now you see that this green solid T, upon strong heating, it gives you a black solid U, as well as carbon dioxide gas. We stop and think for a while, what is it that could give us carbon dioxide gas? Now, if your chemistry theory is okay, you will know that when we heat a carbonate, all the bicarbonates will get a carbon dioxide gas. There's not a bicarbonate here because of two reasons. Number one, there's no water. There should be another product if it's bicarbonate. And secondly, bicarbonate is not in your syllabus. So this green solid must be a carbonate. Something carbonate. Now, this part over here needs you to think, because no matter what carbonate is, it will become a black solid. You might not be able to know this if your chemistry theory is not good enough, but a carbonate, when upon heating, it will always give you an oxide. So this oxide and a carbon dioxide, so this must be something oxide. Now this something oxide will have an acid to give you iron chloride. See, something oxide reacting with an acid, chloride. Now if you think closely, what is acid Z? How many types of acid can you think of? HCl, H2SO4, and HNO3, which is nitric acid. So which oxide react with which acid to give you iron chloride? I think you are right. It cannot be sulfuric acid because it will not give you a chloride component. It cannot be a nitric acid because it won't give you a chloride component. So therefore, whatever oxide is reacted with HCl to give you iron chloride. Now, this is a product of this and this. Where did the iron come from? If you can link it up, this iron must come from here. And this have to be iron oxide. And iron oxide, and this must be iron carbonate. Isn't it? The most difficult part, or the less seldom a lot of students don't understand, is this last part over here. What do you mean upon standing? Upon standing means oxidation. It is as if you cut an apple and the flesh of the apple become brown after some time. What has happened is oxidation. So in this case, whenever you see iron 2 hydroxide upon standing or oxidation, it gives a reddish brown PPT. It means that iron 2 hydroxide has been oxidized to iron 3 hydroxide. And there you have it. If I remove the answers, and there you have it. Now, I will not talk about the ionic equation in this video clip. I will talk about the ionic equations in another video clip. I hope this little video has helped you. Thank you.